Welcome students. Let us see this exercise 2, which is for computer science. So this is based on data types. So let us see this passage. So in programming language, variables are name given to the memory location in which you can store values. Most programming language use the typed variable. What is the meaning of typed variable? So the meaning of typed variable is each variable has one of the several possible data types. It means we have already defined some possible data types and your variable will be one of them. So this is the meaning of typed variable. And the variables are nothing but a name, right? It's a name given to the memory location in the computer. In the Java language, for example, the following data types exist, right? The first one is the Boolean data type. So the Boolean means either it can have true or false, yes or no, right or wrong. If you have two possibility only, so this is the Boolean type and it needs 1 bit of memory. For the short, it is the integer type and the range for is 2 raised to power minus 15, 2 raised to power minus 15 to 2 raised to power 15 minus 1. And the memory requirement is 16-bit, right? For int, see, this is for short, and next is the int, right? Int is also for integer type, short is also for integer type, right? But the limitation is on the memory requirement. Short is for 2 raised to minus 15 to 2 raised to 15 minus 1. This is a range from where to where we can represent. If my number lying between this to this range, I can represent with the short, right, data type, and it needs 16-bit of memory. Int is also integer type. Its range is 2 raised to power minus 31 to 2 raised to power 31 minus 1. And it needs 32-bit of memory. We know that 1 byte, what is the 1 byte? So 1 byte is nothing but 8 bits, right? So we can say that short we should have, see, either we can say 16-bit or we can say 2 bytes. Similarly, for int, we can say either 32-bit or we can say 4 bytes, right? Similarly, we have other data type. The next one is the float. Float is for fractional numbers, and the range for float is we can represent up to maximum of plus minus 10 raised to power 38, and the memory requirement is 32-bit, that is 4 bytes. Similarly, we have the double, and the range is approximately 10 raised to power 308 plus minus, and the memory requirement will be 64-bit, and we can say the 8 bytes. Okay. Next is the string. String is basically character type, so it can have any length, right? The sequence of character of any length is called a string. So memory location, the memory requirement depends on the length of the string, right? The memory requirement depends on the length. Okay, let us see the next lines of this passage. In Java program, a variable can be defined by indicating the type and the name of the variable, right? So first we have to define the type and the name that we will assign to that variable. A location in memory is then reserved. If a value is also specified, this memory is initialized. With example, for example, if we write in x is equals to 5. So this is the data type, right? We have already defined by x is the name of the variable, right? And we have defined that this is the int type, and we have this initialization that is x equals to 5. Now, next we can have a string s is equals to hello. So, and we have a smiley sign also. So these all things will be stored as a string, right? These two examples show integer constant and strings are written. So this is the integer constant and this is a string, right? Floating point numbers consist of digits with a decimal point and or exponent which have or which has a similar meaning as the exponent representation on the calculator. So if we see the first example, that is the float. So float f1 is written as 5.0. We can see here. The next is the float f2 is plus 5 e raised to power 0, or it is written like this. It means it is nothing but plus 5 into 10 raised to power 0. And 10 raised to power 0 is 1. So 5 into 1, that is a 5. Float F3. F3 has been written as plus 50 into, sorry, e raised to power minus 1. That is, we can write 50 into 10 raised to power minus 1, which is again 5. Similarly, F4, it is written as 5.0000 e raised to power 0. So this is nothing but 5.00000 into 10 raised to power 0, that is 5, right? And similarly, the f5 is written as 5f. This small f, if we define, if we write small f after our value, it will tell the compiler or interpreter that this is a float type. So it will store as 5.0 in a float type. Alternatively, it is saying that a small f can be appended to a number to indicate that the type float, right? And small d for double is the important. So all of these five variables have the same floating type value of 5. We have already discussed all these five cases here. Calculations are performed in Java only in int and double. So please see. So in Java, basically we have to consider only int and double. All the calculation will perform on int and double. And if the input data is not int and double, it will be implicitly converted into suitable form. See, the passage is saying the same thing. Calculations are performed in Java only in int and double. This means that there is an implicit type conversion to one of these types. For example, if we have the short, see, if we have the short, it will convert it into the int, right? If we have the float, we will convert it into the double. And for this, we don't have to do anything. It will done automatically. This is the implicit type of conversion, right? This means there is an implicit type conversion to one of these types. Example, short to int and float to double. When any calculation is performed, right? Okay. If two operands are of different types, right, then their value are unified. Then their types are unified first. Then the calculation will be done. So it is saying the same thing. If the two operands are of different types, then their types are unified. That is, int becomes double. And implicit type conversion also takes place during an assignment. For example, if we see this line f6, we have given that f6 float f6 is equals to 5. So this 5 will be stored as 5.0 in the memory. It will store as 5.0 because this is the float type. It is already defined here. Next, float f7. See, next is float f7 is equals to 2 into 2.5, right? See, so 2.5 is a float. This 2 is an integer. See, this is our integer and this is our float. So how they can perform this multiplication operation? So we have to convert them into the same data type. See, this is saying the same thing. In F7, we have a multiplication of an int and double value. The int value is first converted to double. So we will convert this int to double, and this float should also be converted to double, right? Because see, we have two options, double and int, right? See, basically we have short for integer, int for integer, float for fractional, and double for fractional, right? And we have to perform either on int and double. The data given is int, that is the 2, and the float. So if the float is given and one of the int is given, see, float cannot be converted into the integer. So obviously float has to be converted into the double, right? So integer has to be also implicitly converted to double. Then only calculation can be performed. So this integer can be converted into the double. This float will be also converted to the double, and then multiplication will take place, and the result will store as a float. The result is then implicitly converted to float again, right? So we will perform this operation in double data type, but the result will be finally converted into the float data type, right? Calculations in the type int usually return an integer result. We can say the int result. If we have the int type of data, the result will be also int type data. The division is only integer and the ignores the fractional part. Okay, let us see some questions now. You have a variable married that should store the whether a person is married or not. So obviously this should be a Boolean type. So for Boolean, we have two options, the first option and the C option. Okay. The variable age. So age should be in years. So I think this short integral data type will be more appropriate. And a variable name. So name should be written in string. So this C should be our answer. So the answer should be C. See, the in A option, basically this is saying age is in float. So I am considering my age in years only, right? Okay. The question number two. The two values from two float float variables are added. So if we add two float variable, the calculation is done in which data type? So we know either int is possible or double is possible. So obviously float can be converted to the double. So the answer should be double. Two float variable can be added in double data type. It will be converted to double. It will convert it to double, and then addition can be performed. Okay. Question number 3. Two values from two short variables are divided. So we have short, it means integer, upon short, it means integer. So calculation is done in which type? So see, we know that either it can be on int and double. So we have the short, so it will convert it into the int upon int, right? So the calculation is done in int type. So answer should be B. I hope you are getting these questions. Let us see the next one. The following Java program is given short s is equals to 4. So s is a variable and initialization is with 4 and it is a short type, right? The next line it is saying float x and please see x is equals to 3 plus s upon 3. See, this is a short type. This is integer basically. So short will also convert it into the int, right? Because we know that all the calculations can be performed in integer type or double type. So see, integer upon integer, if we divide it, the resultant should also be in integer. So if we divide 4 upon 3, ideally it should be 1.33, something like that. But we have to consider only the its integral part because this is the integer, this is the integer. So the resultant should also be integer. So integral part is 1. So its answer should be 3 plus 1, that is the 4. It's okay that it will be stored as a float. So it will be stored as a float, but so according to the option, this B should be correct. Let us see the next one. You need 1,000 float variables. How many memory location do they require? So we know that one float variable needs 32 bits, or we can say, see, 1 byte is basically 8 bits. So we can say it is the 4 bytes. We know 1 byte is 8 bits. You should remember. So for 1,000 float variables, we need 4,000 bytes, or we can say 32,000 bits. So the answer should be C. The next one. This is also very important. The following Java program is given int I equals to 2. So we have initialized I as 2. Next, double D is equals to, please see, this is the minus I into, this is 1 over I, this plus 1f. Let us see this very carefully. See, first of all, I is an int type. So see, this is also an int. This is also an int. So obviously, when we perform this division, we will get the int type. So see, we will get 1 over 2, right? So what should be 1 over 2? It is 0.5. So what is the integral value? It is the 0 only. This is the integer division type, right? So we can write now minus 2 into 0 plus 1f. So see, minus 2 into 0 will be obviously 0 plus 1f. 1 is f is indicating that this one is a float type, right? This is the integer type. Ideally, they will be converted into the double, right? Because f can be converted to double. This integral 0 will be also converted to double, and then addition will be performed. 0 plus 1 will be 1. So, and it should be stored as a double also. So the answer should be D, that is the 1. So I hope you have understood this question. In the next videos, I will try to cover some more questions based on this passage, similar passage. So if you like this discussion, please like this video, subscribe this channel. Thank you. Thanks for watching.